Welcome to a new test and teardown video. This time it's a Philips signal generator, high frequency signal generator, model GM2882. It's not written here on the front, but it is written on a nameplate on the back. Everything here is written in German, and that is a little bit weird because when I look this up, all I can find is like French schematic and French information as well. So I think this unit existed in a French and in a German version, and I just happened to get the German version. So that is a little bit funny about this one. Anyway, it's not a big deal because we only got those 4 buttons and not that many special features. It should be from around 1939. And I expect to find 4 tubes in this one. Thanks a lot to Radio Museum again for our schematics. And look at the ranges. We got 6 different ranges from 0.1 megahertz or 100 kilohertz to 60 megahertz. That is actually quite nice for a generator not that big in 1939. We got modulation, internal or external modulation, and that will be, of course, AM modulation. The modulation, it says here Ausgang, so that is output, but that is, of course, when it is in output. You can't change the frequency, but when it is in input, and that is here, this is input, and this is the internal modulation. So you can change the frequency you want by coming with an external modulation input. So that is, of course, the tuning of the frequencies, and this is the output level. Look at that one. This is the output high frequency, and this is a thick cable, and this goes to a little output pot. So you can have this close to your test setup, a ground and times 10 and a full. This one was definitely dropped on the floor a few times. It's a little bit rusty here, so I expect to open this and see if I need to service this one. But that is a funny way to do it, isn't it? There is a problem with this switch. I can't move it at all. So we need to open this. I expect to find a very big rotary switch in here, so definitely we need to open. So there's no screws to open it here from the back. We can see it's selected for 220. This looks like a paper, so you can dial this around, I guess. So this unit is, of course, before we had any kind of standards for mains input and chassis grounding. So this is why you find this finger screw here, and then you had to have your own grounding cables you screwed in here. And this is the name plate, GM2882. It looks like we need to unfold this one to see what else it says. 18 watts. So that is what we are expecting. Okay, so that will be the screws. Okay, we have to open anyway. I don't expect a lot of you guys will have this problem. Well, how to figure out how to open this one? That was quite tricky. Yeah, we definitely got a few screws down here. But how do you figure out it's only those 2 screws here in the front? You need to remove. Well, we read the manual, I guess. So we are inside. This is a really nice voltage selector. You just desolder this and put it where you want it. It's easy, only one wire to play around with. So that's probably fuses. Is that the case? No, that's gotta be capacitors to chassis, right? Otherwise I would be worried. Yeah, that would be capacitors to chassis. So that is what it is. That will be the rectifier tube, if I'm not mistaken. Yeah, that definitely looks like that, right? And that will be the two EF50, right? Yes. And the other one will be inside an extra shielded case. And what kind of lock is that? 1947. So this design is from 1939. But this unit is from 1947. And we need to open this case because I can't move the frequency dial. And that one goes with a shaft inside this unit. Got a really nice power on bulb located here. I'm a little bit worried about the wires. They look like they're going to dissolve real soon. That is the frequency. That'll be the output here. That works quite alright. There's something else around here that seems to be... Let's get some light. Is that going? There's a wire down here. This looks a little bit interesting. I need to have a little look. But first let's look inside. Took off all the covers all the way around, and now we are into the carousel switch. So this is the one that selects between the 6 bands. We can see the inductors and the capacitors. That is really, really nice design. The click and hold mechanism here is super tough. Click, and then you need many kilos of force. Oh yeah, look at that. Just this little tiny one winding here. That must be the 60 megahertz. Click. I've been trying to lubricate a little bit here on the shaft down here, and also the frequency adjustment here. I added a tiny little drop in here and in there and in here, because it's full of stuff that was once lubricated with some grease, and that turned into chewing gum. But it started to feel a lot better now, so that is nice. That will be the high voltage filtration. 2 resistors in parallel here to share the power. I was feeling a little bit here on the contacts, and they feel super dirty, like a layer of some nasty stuff here, so I definitely need to clean the contacts. But I also wanted to find this click and hold mechanism here, because that is so tough. But I think it is maybe in here. So to get access to that, I need to take the entire rear plate off as well. And I was a little bit worried about that, because then the whole thing is probably going to fall apart. Hopefully not too much apart. So with the rear plate removed, it was easy to clean up all the old grease around here. So there's of course a ball click that locks into this hole. And if you untighten those two screws, you can move the point and the position of the switches. So it's all about alignment to the contact points here. As you see here, the top is where you want it to stop, right? So that I find tuned. Click. I also bend this springy part a little bit out so it's not so super tight, because it really locks really hard and lubricated the whole thing here. So now you can actually grab from the front, click, click. Now problem is solved. And I could also lubricate that bearing here for the capacitor. And now, while everything is so open, I think it's about time to test it, because now I can also access the capacitors in here if I need to change anything. So yeah, let's see if there's any output. And as always, I want you to see what happens when I turn this on for the very first time. We don't have a light in the lamp. 16 watts, that is not so much. 12, maybe the bulb. Look at that. We got output and a bulb that is not working. Oh, and tuning is working. What is the frequency? 500 kilohertz. So I am in 0.3 to 1. What do you know? That is 5, isn't it? Because this is where I need to look. Up here, right? That is amazing. So that is actually totally correct. Wow, man. So let's try and take the next one. And so this is 1, 2, 3. So that I will be in here, right? 1, 2, 3. So that should be 1.6. Am I lying or something? Let's try and tune this. So this meter says 1.6. Okay. Let's turn off the... Oh, that is 1.6 almost, right? Ha ha! Okay, I've been playing around with the different ranges. So this is the fastest, 30 to 60. And there is a little bit of a problem when I go down here. No output. And I see a lot of modulation like that. Okay. But it goes to 20 megahertz. 45 megahertz. I think my scope is confused about this noise. So that is probably how it is. And there was also a... So this is the 10 to 30. Look at that. Tons of output. Again. We got some... That is not that kind of modulation. Is it that one? No, I don't know. And then the 3 to 10 range, no output at all. So that is probably just cleaning the contacts, or it's something with the carousel switch. So I'll play a little bit with the different ranges, and I will clean a little bit, and then we will see what happens. So that is nice. Okay, we got some funny that is maybe mains frequency. All we have to do is, see, go down to the slowest range and then dial this down to milliseconds. And here you go, mains frequency modulation on top of everything. So we got capacitors we need to look at. That is what we need to do. Ooh, microphone sensitivity. I am actually able to get the 3 to 10 megahertz range to work when I dial around with the carousel switch. So I am able to start it and then it dies out the oscillator. So it's not a problem with the contacts. It's like I'm missing a little bit of gain for the kind of feedback there is in the coils or something like that. So it's not that easy to solve. I think I need to either get a new tube or something like that. I don't know. It has something to do with gain, definitely. Yeah. The others, they start when they go in, click, and then click, and then we're going. Yeah. I could try and swap those two tubes, by the way, because they're the same type. Okay, so that kind of stops the fun a little bit here. So those two tubes are, of course, EF50s, and the oscillator one is in an extra shielded case. I don't know exactly. Let me turn this off. I don't know exactly why you would put a shielded tube inside another shielding, but that's probably because it goes all the way up to 60 megahertz, and you want this to be really nice and shielded. But if you look at this, okay, so that EF50 here is alright, and that socket is also a little bit poked to pieces down here. Let me get some light. So that socket is not that good, but the other one, ooh, see, the tube is like almost falling. See, it falls out more or less. So there's no contact whatsoever in half of the pins here. I don't know exactly what they did. So that was the original, or this one was the one they used for oscillators in here in the middle. This is the chassis. Chassis is connected here, and this way the entire tube is completely sealed and shielded. See, this one goes quite all right. But there is actually no output at all, no oscillations, nothing when I swap those two EF50s. So this tells me there's definitely low gain in those tubes when they can't handle being swapped. So yeah, that is the status of this unit as far as I can say. We need new tubes or something like that to get this thing up and running, or more stable output. So yeah, so far so good. We had fun. Now I can assemble this nice and funny thing again and call it a day. That was fun. That is crazy. I was just sitting here and watching. I swapped the tubes again, and I was just enjoying the glow in the rectifier tube, and I was sitting here and enjoying the output, and then I started to see some spark overs in the rectifier tube. Oh my god, that looks super cool. Let me turn this on and see if we can get this on video. So now the camera is on tripod, And this is the rectifier tube where you need to have a look. And let me turn down the light here a little bit. I'm gonna turn it on. Yes, it's immediately here, right? Do you see that? Okay, now there is a short. Let's turn it on again. Yes, okay. There's a short now inside the rectifier tube. So that is the end of this unit, unless you, of course, change this tube. How cool is that to have this on video? Here is the schematic of this Philips GM2882. As you see here, the EC2 rectifier tube. That is the one that ended up blowing up, and we actually got it on video. How cool is that? Then in the upper left is the EF50 for oscillator. And then you see the carousel switch with all the 6 tuned circuits. And then in the upper right, we have the output amplifier and AM modulation kind of mixer. If we go take the tube in the bottom right, the EF6 tube, that is the modulation oscillator. And then the bottom right switch, that is the modulation switch, where you can select from external modulation or internal modulation or no modulation.